Debería empezar a grabar en cualquier momento. All right, guys. All right. Logarithmic functions. This is today's topic. It's a new topic, a new type of function, but it is so simple that it is going to help us solve another type of question. Yeah, these functions are nothing but an auxiliary function to other types of exercises. All right, let's begin with the easiest. What are logarithmic functions? What are these? All right, a logarithmic function is the inverse of an exponential function. Remember, you guys remember what are inverse functions, right? So for example, if I tell you right now, if I ask you, guys, what is the inverse of addition? Go ahead and write it in the chat, please. What is the inverse? Thank you, Danny. You're correct. Subtraction. Yeah, beautiful. Juan David Vega. Yeah, the -1. Yeah, you guys are correct. Beautiful. Thank you, guys. Thanks to all of you who are participating. Beautiful. I love it when you guys participate. Thank you. Appreciate it, guys. Yeah, and we know this, right? We know this because we have been taught in the past that whenever we want to pass one value to the other side of the equation, right, we pass it with the inverse operation. So if a value is negative, the value is subtracting, so we pass it to add, right? We know this type of things. What is the inverse of division? You guys know that, right? Go ahead and write it in the chat, please. What is the inverse of division? Beautiful. All right. Thank you, guys. Multiplication. Yes, you are correct. Multiplication. That is the inverse of division. So if a number is dividing and we want to move it, we want to isolate a variable or something like it, we want to move it to the other side of the equality, right? The equal. We move it with multiplication, right? The inverse. And right now, I am showing you, I am teaching you that we have an inverse for an exponential function. So whenever we have an exponential equation and we want to isolate the variable, we can do something like this. Let me just cut this. Let's say, for a second, let's say that we have this type of function here. 3 elevated to the x equals, I don't know, 17. I don't know, right? And we want to find this. We want to find the value of x, right? Well, now we can use the logarithmic function because it is the inverse, which means I can pass the 3. I can pass the 3 to the other side of the equality. But I need to pass it with the inverse operation. The inverse operation is the logarithm. So the equation would be something like this. X is the result because I am isolating x, right? And then 3 moves to the other side. This is the way we pass the 3, like this. Of course, I'm going to do this. I'm going to go into more detail, all right? I'm going to go into more detail of this, about this in a second. But if you take a look, now the 3 is no longer on the left. It is now on the right. And we apply it by through the logarithmic function. This is the power of these types of functions. Eh? All right. Cool. Here, definition. This is the real definition. Of course, we're going to do more examples about this. Whenever I give you definitions, most of the times people read them and they don't really understand what is going on, right? It is okay. But after a couple of examples, you guys get the idea, right? So we're going to do that. Don't worry about that. All right. The logarithmic function to the base a, right? Where a equals, where a is bigger than 0 and a cannot be 1, so a is different than 1, right? Is denotated like this. So again, this is the way you write a logarithm. This is the way you write a logarithm, all right? We write it like this. The log, the letters L-O-G, right in the corner of the g, we're gonna write the base of the logarithm, and then a big value. And I'm not saying big in magnitude, like 1,000, a million. No, I'm saying a big number. This is a small number. This is a big number. All right. So that's what I'm saying. You're gonna write a big number here. This is the big value. All right. We have a couple of conditions. Number one, this value, the a, the base of the logarithm, has to be bigger than 0. Also, cannot be 1. Has to be different than 1. So if, I don't know, maybe in a quiz or one of the books say something like this, what is the logarithm base 1 of 7? All right, this is a mistake, right? This is a mistake. We cannot do something like this. We can't, right? Why not? Simple. Because the base of the logarithm is being 1. And we know from this, we know the base cannot be 1. Another example, another one. Let me write it here. Another example. Logarithm to the base -2 of, I don't know, 90, whatever. This is another mistake. This is another mistake, right? Why do we know this? Simple, because a has to be bigger than 0. So it has to be positive, a positive value. -2 is not bigger than 0, it's negative, right? All right, beautiful. We have those two conditions. As long as we keep those two conditions, then we have logarithms. And just like any other property, you can write this. I'm sorry, and just like any other operation, you can write this in the calculator. You can write logarithms in the calculator, and the calculator will give you the answer. I'm going to teach you that later. All right, but how do you read this? Remember, mathematics is a language, right? So we not only need to know how to write it and solve it. No. We need to be able to read it properly. This is how you read it. Y is the logarithm to the base 8. To the base. That is how you read it, to the base. So something like this. 7 is the logarithm to the base n of W. I don't care. Something like this. This is how you read it. 7 is the logarithm to the base n. That is how you read it. To the base and of, and then the big value. In my case, W, of W. All right. Let's continue with this. Now, we have a quick way to transform a logarithm into an exponential and an exponential into a logarithm. Take a look at this. You can change logarithms like this. All you need to do is follow the order. That is all you need to do, just follow the order, right? So you can change this expression into this one. Remember, you can change a logarithm to an exponential. And also you can change the exponential into a logarithm. How do you do that? It's pretty simple. Just follow the order. Whenever you find the exponent, you locate it in the other side in the position where the exponent will be. Since I'm calling the exponent y, the position will be here in y. I'm going to do an example about this right now. Here, let's do the first one. 1.2 to the third power equals m. 1.2. Let me erase all of this. And let's do it with blue. 1.2 to the third power equals m. Right? Take a look at these. We're going to find equivalent logarithmic expressions to the first one. So we want to change this expression, which is clearly an exponential. How do we know? Simple. Because it has an exponent. That's it. It has an exponent. So it is an exponential. This one has an exponent. So it's this one over here. It's that simple. All right. We can change this exponential into a logarithm. We can do that. How? We're just going to follow the process, the instructions. All right, let's find our variables. All right, notice how we have a base, and also here we have a base. The base is the one we call A. So in our example, A is 1.2. Did you see? A is 1.2. Also, we have an exponent. The exponent is the one we call y. So in our example, y equals 3. Did you see what I'm doing? Did you see what I am doing? Huh? All right. And last, we have the solution of the exponent, which is this one over here, the power, the solution of the exponent. In our case, the variable x is going to be, for us, the letter m. Apply these 3 and change this into a logarithm. How? Just following the order. First, we're going to write y, which is the solution. So in our case, 3. Huh? Equals to log to the base a. So logarithm to the base a. But wait a minute, what is a? Oh, look at this. A is 1.2. So I'm going to write the 1.2 right here. 1.2. Huh? And last, we have the value x. But what is the value x? For us, the value x, look at it, it's right over here, is the m. So we put the m here. And just like that, we transform. Let me erase this like this. Beautiful. All right. And just like that, we transform an exponential into a logarithm. How do we know we did a good process? Again, because we don't have more values than the ones we are presented at the beginning. We have 1.2, we have a 3, and we have an m. And right here we have that. We have a 3, a 1.2, and an m. All we are doing is reorganizing the expression so that now it contains a logarithm. That's it. And we can do it with this expression over here. Right, let me erase all of this. Let me erase all of this. Now, can we do it in a different way? Yes, we can. Just like I showed you at the beginning, we can do it in a different way. La-da-da. La-da-da-da-da. You don't have to memorize these bunch of letters and this organization. You don't have to do that. You can just apply the idea of logarithms. Logarithms are the inverse of exponential functions. So if I want to change this exponential function, again, 1.2 elevated to the third power equals m. This is an exponential function, right? And we want to change it, or not function, but expression, or maybe function, whatever. And we want to change this into a logarithm function, right? How do we do that? Why don't we isolate the 1.2? Why don't we pass the 1.2 to the other side? Huh? If I want to pass this one to the other side, well, we recognize that this is the base of an exponential function, right? This is 1.2 to the 3. This right here is part of an exponential. So if I want to move it to the other side, I need to move it with the inverse operation. What is the result then? All right. Well, what is left to the left of the equal is the 3, right? Again, we are moving the 1.2 to the other side. So we are left with the 3 alone. Over here, I have the log. And remember, why do I have the log? Well, because I am moving the 1.2 to the other side. And logarithms are the inverse of exponential functions. So logarithm of 1.2. That is the value I just moved, 1.2. On the other side, I also had the m. So there we go. And look at that. Look at that. I did this without having to memorize these bunch of letters and organizations. Just with the idea of what a logarithm is. You can do both. Guys, you can do both. If you like formulas and letters, you can do this process. But if you hate having to memorize that, why don't you just apply the inverse of the exponential and pass one value to the other side? Huh? All right. Okay. Beautiful, guys. All right. That being said, I want you guys, all right, the solutions, right? So the first one is 3 equals logarithm to the base 1.2 of m, right? We did this already. I want you guys in the chat, please, to give it a try. I want you to give a try for the second exercise. Give it a try. Tell me, what would be an equivalent logarithmic expression for the number 2? Change it, please. Remember, it is okay to have mistakes. You're just learning, right? So don't worry if you have a mistake. And I'm not going to read answers if, maybe you're ashamed that I do read your answer. Don't worry. But I want all of you to give it a try right now in the chat, please. Elevator music while you guys write your answer. All right, let's see the answer. Wow, look at that. Beautiful, guys. All right. Beautiful. Yes, correct. Yes, to all of you. I haven't seen one single answer that is not correct. Look, like I said at the beginning, I'm not going to read the answers because you guys might feel ashamed. So, whatever, I'm not going to do it. But right now, everybody is correct. This is the answer. B equals logarithm to the base E of 9. Congratulations, guys. Yes, yes. How did you do it? I don't know. Maybe you did it with the expression one, right? And the bunch of letters and the values and all of that. Maybe you did it that way. That's okay. Or maybe you apply what I just teach you about moving one value to the other side. I don't know. Whatever your result was, you did it perfectly. Pretty good. Now, here's the thing I want to teach you about logarithms. Here's the thing I want to teach you about logarithms. Take a look at this. Please do not move your eyes from the screen right now, because what I'm about to show you is completely new. Completely new. Guys, in mathematics, whenever we find this log E, log to the base E, this in mathematics is a special, it's a special type of logarithm for us mathematicians, right? This is the one kid that we love. You know, we have a lot of kids, we have a lot of sons, but this one, man, this one we love. This one is a specific type of logarithm. So whenever we have this type of logarithm, logarithm to the base E of any value, right? Doesn't really matter what value it is. We say that that value is a natural logarithm. This is a natural logarithm. Of course, we are applying the logarithm to the base E of a value. Now we have the natural logarithm of the same value. What is this? ln. What is this ln? All right, this ln, as I said, is the natural. Sorry about my handwriting, guys. Natural logarithm. Logarithm. Sorry about my handwriting, guys. The natural logarithm. En español se lee así también. Logaritmo natural. LN, logaritmo natural. Right? Why do we say that this is a specific type of logarithm? Why do we do this change? Look, if you go to your calculator, you're going to find that you have a key for log. Hopefully you guys are using your calculator right now as I speak, right? You're going to find that you have a key for logarithm. And right under that, you have a key for natural logarithm. That is how special the natural logarithm is. We even have a dedicated key for the natural logarithm, the logarithm base E. That is how special it is. Why do we call it like this? I don't know. The reason why we call it natural logarithm, I'm not sure. But the reason why it is special is because this letter E is a value that is special for us. Just like in mathematics, the value pi is a special value for us. right? This is not a variable, right? This is a a value, a number, 3 point something, 3 point stuff. This is a really specific and really important value for us in mathematics. And this one, the value e, is another one that is really, really, really important for us in mathematics. So this is not a variable, guys. Logarithm to the base e. In mathematics, we don't use the e as a variable because e has a specific notation for us and a specific value. If you go in your calculator and press the key e, it is going to tell you the value is 1.4 something. 1 point something, 1.41 something. Right? 1.2 something like that. I don't remember, to be honest.
Mister, a mí me aparece 2.71.
All right, there we go. Thank you. 2 point something. Beautiful. This is a specific value. Right? This is a specific value. Just like pi. Thank you, Alba. These two. And just because of that reason, in mathematics, we have created a specific logarithm for that. A specific logarithm. Which is why whenever, guys, whenever we find the logarithm to the base e, we are not going to write it like this. No, no, no. Not anymore. No, we are not. We are not going to write it like this. We are going to write it like we are supposed to. The natural logarithm of 9. That's it. In today's exercises, you are going to find this expression in some of the exercises. ln of 9. You're going to find that. But now you know that the ln is nothing more than the logarithm to the base e. So now you can change and do your mathematics. All right, guys, please don't forget about this. ln is a specific type of logarithm. So whatever I teach you about logarithms also applies to ln. All right. Last but not least, the final one, right? A elevated to the 4th power equals 24 is going to be like this. 4 equals the logarithm to the base a of 24. All right? Beautiful. Beautiful. All right. Let's try to go into more detail about logarithmic functions, right? I like to say that logarithmic functions look for the exponent. What? Here's an example of what I mean. Take a look at this. What is this, guys? Logarithm to the base 2 of 8. What is this? What is the value of this? How much is this? As I said at the beginning, this is an operation. Logarithms are operations. So if I ask you how much is 2 plus 8, you should know, right? You know how much is 2 plus 8. If I ask you how much is, well, I don't know, 2 multiplied by 8, well, you know the answer of that, right? Those are operations that we use pretty much daily. But if I ask you this one, what is the logarithm to the base 2 of 8? I'm sure you guys don't know. Well, this is also an operation. And we can find this value. We can find this answer. Number one, we can do this with a calculator. So you take out your calculator and you put this in the calculator and you are done. This is going to tell you the answer. All right. But if you don't have access to a calculator, how do you do this? How? Again, pretty simple. Whenever in mathematics, how much is this, right? That's the question. We are looking for this. We don't know, and that is what we are trying to find. How much is this? But remember, in mathematics, whenever we don't know something, we call that an x. Logarithm to the base 2 of 8, we don't know how much that is. So that equals x. And now, the rest of our procedures will evolve around finding the value x. Since we don't know, we call it x. But look at this. This is an a logarithmic expression, right? It has a logarithm on one side and it has an equal. So this is a logarithmic expression. All right. Since this is a logarithmic expression, we can change it into the exponential form. Look at that. Again, we can do this simply by moving the logarithm from one side to the other. But if we move it to the other, we're going to have to move it with the inverse operation. The inverse of logarithms are exponentials. So now we have 2 elevated to the x. This equals 8. All right, look at that. Now we ask ourselves, what is the x? Well, x is the value that we have to elevate the 2 so that we have 8. 2 to the what? That is the question. 2 elevated to the what gives me 8. Well, 2 to the 1 is 2, so no, x is not 1, right? 2 elevated to the second power, that's 4, right? 2 to the second, that's 4. So x is not 2. How about 2 to the 3? 2 to the third power. 2 times 2 times 2. That is an 8, right? So just like that, we found the value. X is 3. Huh? But remember, what was x? X is our solution here. This is x, the solution for the question, logarithm to the base 2 of 8. So now we know the logarithm to the base 2 of 8 is 3. How much is this? How much is logarithm to the base 2 of 8? It's 3. Because now we are asking, what is the value that we have to elevate the 2 so that it gives us 8? You see? Logarithmic functions look for the exponent. Whenever you have these type of questions, you know that you are looking for an exponent. What is the value that you need to elevate the base so that you get the value, the big number? 2 to the what gives you 8. That is a logarithm. Logarithmic functions look for the exponent. All right, pretty good. All right, let's jump into some basic facts. Number 1, whenever you guys find something like this, the result will always be 0. Let me do an example of this. This is a basic fact. Quick example, take a look. What is the logarithm to the base 7 of 1? How much is that? Well, according to our basic fact, the result is 0. But why? I don't understand, teacher. Why? Simple. The basic fact is telling us that whenever we have a logarithm, no matter what the base is, so we can have 7, or we can have 8, or we can have 1,000 millions, it doesn't matter. So long as the big value is 1, the result will always be 0. So how much is this? Logarithm to the base 0.01 of 1. How much is that? In the chat, please tell me, how much is this? Tell me the result, everybody. I think you got it by now. How much is this? All right, thank you guys. All right, pretty good. The result is 0. Again, why? Because of our simple fact. The simple fact, remember, no matter what the base is, if the big value is 1, the logarithm is 0. All right. Let me erase all of these. Oh, no. Of course, we have one condition, right? Do you guys remember this condition? How much is this? Logarithm to the base 1 of 1. How much is that? How much is that, guys? This is a trick question. Don't say 0. Even though the big value is 1, this is a trick question. The answer is not possible because the base is 1. Let me go back a while. Look at this. The value a, the base of the logarithm, cannot be 1. Remember, we had 2 conditions. Any logarithm, the base has to be bigger than 0, so positive, and cannot be 1. Those are our 2 conditions. So if I move to the basic fact here, the base is 1. So this is not possible. Same as if I do this, logarithm to the base -7 of 1. Even though the big value is 1, we still say that this is not possible because the base is negative. Remember those 2 values, please, those 2 conditions. All right, that is our first basic facts. Why is this? Why is this? Simple. Because if we change this to an exponential form, we have 1 equals a elevated to the 0. And this is one of the properties for exponential functions. Again, let me explain what I just did. I changed the logarithmic expression into an exponential expression. Look, I moved the log to the base a to the other side. So I have it as an exponent now. So I have 1 equals a to the 0 power. This is one of the properties of exponentials. Remembers? Did you guys remember? Remembers? This is one of the properties of exponential functions. Any number elevated to the 0 is 1. Which is why this is a basic fact. This is very basic. This is the reason, right? Let's change into another one. Here, number 2. Whenever we have logarithm of any base, logarithm to the any base of the same value than the base, the result is 1. Let me do an example of this. There. Do an example of this. How much is the logarithm to the base 5 of 5? Look, we have the same base than the same big value. Base and the same big value. The result is 1. This is simply because we have it as our basic fact. Now you guys try it. How much is this? The logarithm to the base 100 of 100. Tell me, everybody in the chat, how much is this, please? All right. I'm just doing this to see if you guys are paying attention. Of course, I know that you guys know this is 1. Beautiful, guys. Correct. Of course, don't forget about our conditions. How much is this? Logarithm to the base 1 of 1. In the chat, please, everybody, how much is this? Logarithm to the base 1 of 1. How much is that? Beautiful, guys. Excellent. Not possible. Don't forget about the conditions. The base cannot be 1. You guys are doing it beautifully today. Thank you, guys. Appreciate it. Also, even if I do this, logarithm to the base -2 of -2. The base cannot be negative, so it is also not possible. Beautiful, guys. Perfect. Now let's jump into the why. Why is this a simple fact? All right. All we have to do to analyze this is do the same that we did in the previous one. We are going to change this into an exponential form. Look, I'm going to move the log to the base a. I'm going to move it to the other side. So I have, as a result, the big A. And in the other side, I have the base A to the 1. And this is one of the properties of exponentials. Any value elevated to the first power is the same value. Did you see? This is why this is one pretty basic fact. All right, let's move into another one that is not so basic, is not so simple. Our basic fact number 3. Whenever we have a base, a power, this is a power, right? This is a power. So an exponential expression, a power, an exponential expression. But in the exponent, we have a logarithm. What is the result? Well, the idea behind this is you can cancel these two. Remember how I said at the beginning that logarithms were the inverse of exponentials? Well, just like any inverse, whenever you have them together, the two inverse operations, you can cancel them. So here we have an exponential and a logarithm, and they two have the same base. So whenever we have the same base, the exponential and the logarithm gets canceled. So we are left with the m alone. M equals m. This is why This is a basic fact. Let me do an example of this. Example. How much is 7 elevated to the logarithm base 7 of 9? How much is that? Well, all right, guys, you're getting it. Beautiful. All right, pretty good. As we can see, we have a power, and in the exponent, we have a logarithm. And look at that, the bases are the same. So we can cancel these two, and we are left with the 9 alone. Yes, beautiful, guys. Beautiful. Perfect. Beautiful, guys. You guys are doing it great. Beautiful. All right. Next, our final basic fact. And you will see that that basic fact, it is really, really, it can get confused. It can make you confused, right? Logarithm to the base a of a to the r. But if you analyze this, behind this, what we have is a power between or in the middle of a logarithm. So we have power and logarithms, exponentials and logarithms. And these two have the same base, which means, since they are inverse, we can cancel them. And we are left with r equals r. R equals r. This is why this is a basic fact. But again, remember, you can only cancel logarithms and exponentials if they have the same base, all right? So let me do an example of this. Example, how much is this, guys? The natural logarithm of e to the 7. How much is this, guys? How much is this? All right. So now you're saying, what? I don't know, teacher. You said something about ln, but I don't remember. All right, remember. ln is the same as logarithm to the base e. So what we have here is logarithm to the base e of e to the 7. So we can cancel the natural logarithm with the e. Right? We can cancel those two. We can cancel them. And we are left with the 7 alone, which is what the result is saying. 7. All right. Again, remember, ln is a specific type of logarithm, but every single thing that I have been teaching you about logarithms apply to ln as well. All right. Let's change into what we came here today for. Some exercises. All right. All right, guys. I want you to go ahead and work on these exercises, please. Remember, you only have to do the odd ones, the odd ones. All right. And that's it for today. Remember, if you have any more questions, I am here for you. I'm going to stop the recording now. But again, if you have any questions like, teacher, I couldn't do this exercise. Can you please explain me? Or, teacher, can you do this exercise? I want to see if I have it right. I want to check my answer. Something like it. Don't hesitate, guys. I am here for you. And let's stop it right now.